All right, in this video, I'm going to walk through a few more examples. I'm actually going to go through the gravitational force calculations quiz from Tuesday, November the 3rd. I'm not going to go through the entire quiz, not every single question, but I will go through a few examples. You can also see that I have my equations handy. Since I'm doing this all on my computer, obviously I can't write out my work for you to see, but as it says in the quiz, I do recommend that you write your work out on a separate sheet of paper, and that way if you have questions, if you miss things, you can show me the picture and we can try and figure out what you did wrong. The other thing that I would like to say, if you are using your phone as a calculator and you find that you are not punching things in right, or you're not really sure how to do the numbers with the exponents, or if you're just looking for a different calculator to use, a student was using this one in class the other day, and I have found that it's a really good scientific calculator. So you can see the website desmos.com/scientific. There actually is a link on the Canvas homepage that will take you to this. And this is the one I'm going to be using as I walk through how to punch things into the calculator. So this could be really helpful for you as well. So let's start with this first question. A doctor with a mass of 97 kilograms is standing 2.5 meters away from his patient who has a mass of 43 kilograms. What is the gravitational force between them? So the first thing is to figure out what you know and what you're looking for. Well, we know right here, what is the gravitational force between them? So we know we're looking for force, or Fg. Right here it says a mass of 97 kilograms, so that's your clue that it's a mass. Even if it didn't say mass of, your units here, kilograms are used to represent mass. So that is a clue if you're unsure of what variable it is. So 97 kilograms is a mass, 43 kilograms is a mass, and then 2.5 meters away. Remember that gravitational force is directed between the centers of two objects. So you're looking at how far away from the center of one object is the center of the other object. And that's going to either be given as a distance in meters, 2.5 meters away. If you have something that is, say, on the surface of a planet, that distance, d, is going to be the radius of the planet. And then we always have what we call big G. And the value of big G you should have written in your notes, 6.67 times 10 to the negative 11. You always include that in your calculation. It's not going to be given to you in the problem because it's a constant. Constant meaning it's just the same number every time. You just have to remember to plug it in. So let's punch this first one into our calculator. What is a gravitational force? We know that we're going to use this Fg equals G times mass 1 times mass 2 divided by our distance squared. So on our scientific calculator down here, there's this nifty little button over on the right that lets you make a fraction. So you don't have to worry about, did I put the right number in the right spot? Did I multiply when I should have divided? Anything like that, because you're just building a fraction, just like your equation here. So the first thing I'm going to put in, and I'm going to put all of my numbers in parentheses to make sure that they're clear, is my big G. So 6.67, and I'm typing that on my keyboard, times 10, and then we're going to do this little a to the b. A to the b is going to let me add an exponent onto my 10. If I can click it correctly. There we go. And it's 10 to the negative 11. So I'm going to type in negative 11. And then I'm going to close my parentheses. And my next number is going to be Mass 1 and Mass 2, it doesn't matter which one is which as long as you have them both in there. You can call either one of them 1 or 2. So my first mass is 97 kilograms. And then my second mass is 43 kilograms. So that's my G times M1 times M2. On the bottom of my fraction is my distance squared. So I'm going to put in 2.5. And then this A to the 2, or A squared, is going to square that number for me. So I can go ahead and hit enter, and my answer is already right over here. As I'm typing in my fraction or typing in my numbers, it's actually giving me the result over here. So 4.4512912, we don't want to keep that many digits, but times 10 to the negative 8. So when I come over here to my answer choices, I can see 4.5 times 10 to the negative 8, and my units are newtons. So you can see right here, if I round this, 4.5 times 10 to the negative 8. Now let's look at some where you have to enter your own number. And something that might help you with these, you're never going to have to enter an exponent in any of these fill in the blank type questions unless it specifically says how that I want you to enter the exponent. You're not going to do it. So if you get a number that looks like this on a fill in the blank question, then something has gone wrong somewhere. So let's look at this first one that's talking about how far apart are they. Two pieces of space debris with these two masses exert a gravitational force of this many newtons on each other. How far apart are they? So I'm going to come over here to my equations. How far is a distance? So I'm looking for a distance apart. I've got two masses, 864.6 kilograms and 1442.3 kilograms. So I know my G always. I've got a mass 1, I've got a mass 2. They exert a gravitational force, 8.4 times 10 to the negative 11 newtons. So I've got all the pieces that I need to plug into my equation. This one is really important to watch out for your square root sign. Make sure that you're square rooting. And again, if you use a calculator like this one, you can just build the entire equation all in one spot. So I'm going to do square root, hit my radical, and then I'm going to come over here to my A over B, my fraction button again, because there's still a fraction underneath my radical. And then I'm going to plug in all my numbers just like I did before. So open parentheses, 6.67 times 10, this A to the B will let me put in my negative 11, and then click to close the parentheses so that you're not just putting parentheses around the 11. And my mass 1 and mass 2, so open again, mass 1, 864.6, close, and my mass 2, 1442.3, close those parentheses. And notice how my radical is going over the whole thing, so that's good. I want it to do that. On the bottom of my fraction is the force, 8.4 times 10 to the A to the B, negative 11. Just to be safe, I'm going to put parentheses around that to make sure that the calculator does understand that that's all one piece. And it does, and it's giving me my answer, 995.0815. Again, we don't want to keep all of those numbers. Right here, it's going to tell you round your answer to the nearest 0.1. That means the tenths place, 1 decimal point. So 995 point, and I'm going to round that up to a 1 because my next number is higher than 5. So 995.1. And if I were writing this down, it would be in meters, 995.1. Let's scroll down a little bit farther and do a mass question. Okay, a person weighs 6.5 newtons on the surface of planet X. If planet X has a mass of 2.73 times 10 to the 24 kilograms and a radius of 4.8 times 10 to the 7 meters, what is the person's mass? And I've got a little reminder here. Remember that weight is a force, and your weight is equal to the gravitational force between you and the planet that you're standing on. So in this case, our weight, 6.5 newtons, is the gravitational force between the person and the planet. So again, if you're not sure which variable it is, look at the units. That's your clue. So newtons is a force. Newtons is always a force. Even if you're not sure which force I might be talking about, if you're unclear on that, always know that newtons is a force. So again, I'm given the mass of the planet, I'm given the radius of the planet. Remember, if you are on the surface, so I'm drawing a little circle with my mouse. Here's a planet. If you're on the surface, the distance between the center of you and the center of the planet is going to be the radius of that planet. So that is your D. So what's the person's mass? I'm going to go to my mass equation. And in your journal, it probably says M1 is equal to all of this. This one says M2 is equal to all of this, but guess what? It doesn't matter because you're going to call one of them 1 and one of them 2, and either way, your equation is the same to find a mass. So let's come down here to our calculator. And I've got force times distance squared divided by big G times the other mass. So I'm going to build my fraction, A over B. And what's my force? 6.5 newtons. So I'm going to plug in 6.5. My distance squared, so open parentheses, my distance, 4.8 times 10 to the 7th, so 4.8 times 10, do this little A to the B, and plug in 7. I'm going to close that parentheses and then do A squared so that it's squaring that distance calculation there. And then divide it by big G, 6.67 times 10, A to the B to the negative 11. Close my parentheses, and then times the mass, in this case the mass of the planet, 2.73 times 10, and then do A to the B to the 24. Close my parentheses, and here is my answer, 82.24459 blah blah blah. Rounding my answer to the nearest 0.1 to the 10th place, 82.2. So if a person weighs 6.5 newtons on the surface of planet X, then that person's mass is 82.2 kilograms. I'm going to do one more for you because you've got several of these. How much would this person weigh on the surface of this planet? Okay, I'm going to do this one that's Mars. How much would a 77.4 kilogram person weigh on the surface of Mars? Okay, and I've given you some additional information here. Weight is a force, so if you're looking for weight, you're looking for force. If you're standing on the surface, the distance between your centers is the planet's radius, so D is the radius. You've got mass here for the person, mass here for Mars, and a distance here, that's the radius of the planet. So we're looking for force. Come back over here to our original equation, G times M1 times M2 divided by distance squared. So I'm going to plug all that in my calculator. A over B gives me a fraction. Open my parentheses, 6.67 times 10, and then A to the B power, negative 11. Click, close parentheses, open again, my mass 1, 77.4 kilograms, close parentheses, open them again. Mass 2 is going to be the mass of the planet. I'm going to type this one, 6.43 times 10 a to the b, to put in your exponent, to the 23. Click and close parentheses. On the bottom is distance squared. So open parentheses, 3.40, whoops, careful, I want to type it into there, 3.40 times 10 to the 6th, so a to the b, 6, close parentheses, whoops, don't want to do that, so I'm going to just hit backspace, click close, and I'm going to square that distance, so a squared, and my answer, 287.157, blah, blah, blah. Round your answer to the nearest whole number. Nearest whole number means no decimal places, so just before the point. So 287, I'm going to leave it as a 7 because my next number is a 1. So 287 newtons if we were writing our units because we're looking for weight. So 287 newtons. And the last question I'm going to go over is this one right here, question number 8. This one is not a calculator question, not really. It's really about the proportionality. And if you look at the beginning of Monday's video, I talk about proportionality. The force of gravity between two objects is 20 newtons. If the distance between them is cut in half, what is the new force between them? So if we look at our equation over here, and I'm going to write on it just a little bit. If we leave g out of it because it's a constant, and I know that my force is 20 newtons. If I cut my distance in half, so 1/2 of my original distance, what's the new force? So if you change one thing on one side of the equal sign, it's going to change the other thing. And force and distance are what we call inversely proportional, which means if one goes up, the other one goes down. If one goes down, the other one goes up. So if distance goes down, meaning it's cut in half in this case, so distance has gone down, we know that force is going to go up. So if you look at your answer choices, you can eliminate right away. 10 is not an option because we know that it's going to go up. 20 is not an option because we know it's going to go up. So it's not 10, it's not 20. So what we have to figure out is our new force going to be times 2 or times 4? So you go back over here and you look at 1/2 of our distance, but we still have to square that. Okay, 1/2 times 1/2 is equal to 1/4. So in order to figure out what we're doing over here, we're dividing by 1/4. But when you divide by a fraction, you multiply by the reciprocal, meaning you flip your fraction over and multiply by that. So instead of dividing by 1/4, what's actually happening is we're multiplying our force by 4. So 20 newtons times 4 is going to be 80 newtons. The last two questions are asking you about what's happening to the force. Again, that's a proportionality thing. If you're doubling the mass, then you double the force. If you double the distance, then you cut the force by 1/4. And so that's something that you'll need to go back to the other video to get a little bit more detail on. But the best advice I can give you as far as reading your word problems is to look for units. Units on the numbers will be a clue as to which variable it is. And then there's just a couple of things that you need to keep in mind if you can't. If you're having trouble remembering, write them down. Weight is a force. FW equals FG. Planet radius is going to be the distance in any question that asks for it. So write those things down. Please ask if you have questions. Again, write out your work while you're solving these problems, and then if you do have an issue, then we can figure it out together.